Hi everyone. In previous session, I talked about overall concept of container engine, but in this session, we are going to dive deep into the concept and architecture of Docker engine. As you can see here, Docker client will be in touch with the daemon, and the daemon is constantly in touch with containerd, and the containerd will be in touch with the runc in order to run a container. And just in order to show you that plugins can also be attached to the overall Docker engine, I will explain all these components in next depiction. Okay, let's jump into the details. Uh, you start by running a command inside your Docker client machine. What will happen? The Docker client will be in touch with the Docker daemon through a RESTful API, which can be an HTTP based API via GET or PUT requests. Okay, but what is the medium between this Docker daemon and Docker client? If your Docker client staying and existing in the same machine that your Docker server is running, then this uh, connection will be happen through internal Docker sock, which is a Unix socket. You can see here, I just ran ls-li docker.sock inside var/run, and it is showing me the small s here, which is actually a Unix socket. But what if you are a client not existing in the same machine which is running your Docker server? In this case, which is the most common case in big environments and in production, this connection to the daemon will be happened to TLS securely. Okay, so you can securely connect to your uh, Docker daemon via TLS. I will discuss about these two scenarios later on. But once this command such as docker run -id-d alpine been run in your command line, the Docker daemon main purpose and responsibility is push and pull images securely through authorization and authentication. Receive instruction at exposed API, exposed endpoint from Docker client, and instruct container D to start new OCI. I have talked about OCI, Open Container Initiative, which is our standard. So as you can see, No, the Docker daemon and containerd are coexisting inside the same machine. So they are actually existing inside same host in this case. Okay, so in this case, the only option is internal connection via this socket, which is in this case a container socket. And the location is in var/run/containerd. So there is no TLS option more because it is completely internal. And the type of the API which being used is again HTTP or HTTP version 2. We will go to, this is gRPC, which is a Google uh, specific API, but already been, I think, uh, donated by Google to the community as an open source API. But this is another type of API which will uh, cause the connection between Docker daemon and the container D. So what is this container D is doing? Container D is responsible for container lifecycle operations like start, pause, RM. It can also provide push and pull images, just like Docker daemon. Uh, you will see this in Kubernetes later on. Just as an example, let me run this command, docker stop opensive barnel, which is the name of the Alpine container, Alpine Docker container, which I created firstly. And once I stop this one, I can be in touch with containerd. But before that, once I tried to run docker run dash it dash d alpine, actually tried to pull an image and run the alpine container inside my docker server machine. So this docker container instruct the low level runtime run C. I discussed about these runtimes in previous session. Okay, so this will actually instruct or low level runtime run C uh, to create running containers. Once run C, forget this container D shim for now. Once this run C, create this Docker, create this running container, it is acting just like a parent to these running containers. And these containers are definitely the childs of runC. But this parentship won't take too long because after a while, uh, container D sheen, or which is used to be Docker sheen, but at the moment it is container D sheen, will take the responsibility of keeping standard in, standard out open, makes the container independent of the daemon's status, such as restarts or reporting the container's exit status back to the daemon. It will become container's parent after runC process exits. So the main purpose of runC was just creating this running container through being a CLI wrapper that create the container and then exit. Okay, to have a better idea about this parentship transformation, you can see that in this depiction, in which container D, Shin, will be exist on top of run C, and after exit of run C, the Shin become the container parent. So this parentship will happen.